Okay, so my doctor was a bust because it was not today. It was next week, February. This is this part, so the back of the um, similar triangle. So we'll quickly do this. So again, the idea here is to set up proportions and just make sure that you set them properly. Okay. Here we go. So we have a giraffe, and I'm gonna put the giraffe that's 18 feet tall, and is casting a shadow that's 12 feet. And then there's Corey, who's 4 feet tall. Oops. Corey has a shadow, sorry, who's 4 feet, and we want to find his height. So that's how we draw it. So again, in my proportion, so it's 18 feet to 12 feet, and that on this side corresponds. So 18 feet corresponds to x, and the 12 corresponds to 4. And if we cross multiply and do all that stuff, we can easily. And this one actually we don't even have to because it's a nice relationship. Divide by 3. So divide by 3. It means that Corey is 6 feet tall. So sometimes we don't have to cross multiply. So there's a Ferris wheel, and there's a shadow. It's 20 feet tall. Man is here, and his height is 1.8, and his shadow is 2.4. So again, it's 2.4. That's his shadow in meters, right? This is all meters. And we want the height of the Ferris wheel, so that would be my x. So again, x 20, 1.8 to 2.4. That would be my my proportion. X corresponds to 1.8 and 20 corresponds to 2.4. I don't know what relationship there is here, but I would probably cross multiply. And if I cross multiply, I get 2.4x on one side and 20 times 1.18. 20 times 1.8 equals blah 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 36 divided by 2.4. And the Ferris wheel is 15 meters tall. Really? It looks so big. Yeah, well. Okay. Small Ferris wheel. 9. Flagpole. Again, flagpole. There's a shadow which is 28 feet. Person standing. Cast a shadow of 8 feet. And this is all the information that I have. So this is my x. And again, x to 28. X corresponds to 6, and 28 corresponds to 8. We can 3/4. So instead of 6/8, we can write 3/4. And now there's a relationship, which is times 7, and then on top is times 7. So 3 times 7 is 21. So the height of the flagpole is 21. This is 21 feet tall. Photograph measures 4 inches wide and 5 inches long. So it's a 4 here and 5 here, the photograph. And then it's enlarged to make a mural, so something much bigger. The mural is 120 inches wide. What's the height here? That's going to be our question, right? So set up our proportion. So it's 5 to 4. And that's going to be my x. 5 corresponds to x, the height of the mural. And 4 corresponds to 120 over here, the width. So it's times 30, times 30. So that means this is going to be as high as 150. Not as high as 150, it's going to be a high 150 inches high. 11. So there's a building, and there's the ladder. Okay, so there's the ladder, and the ladder, 9-foot ladder. So this is 9 against a building 6 feet above the ground. This is 6. At what height would a 15-foot ladder touch the building? Both ladders form the same angle with the ground. So now this is a 9-foot ladder, and let's imagine a 15-foot ladder. Alright, so how far is this? So we're looking, this is my x over here, right? Because obviously 15-foot ladder, if it's the same angle, it's going to touch, I think, a little bit higher. So such a proportion, so we can write on one triangle 9 over 6, and that 9 corresponds with the 15 on that side, and the 6 corresponds with the x. Let's simplify here, divide by 3, right? So this is actually 3 over 2, nice and easy, times 5, and our height here would be 10 feet. Okay. 12, which wants to reduce triangular pattern with sides 16, 16, and 20. So it's an isosceles triangle. So let's make this 16, this makes 16, let's make that 20. If the longest side of the new pattern, the longest side is 15, what should the other sides be? So we can call this x, and obviously the other side I'm going to call x. So we don't need to find the other side, because once we find this one, we can find the other one. So here's my, and I should have made that triangle a little smaller, so let me redo my drawing. So we're going lower. The triangle is going to be a little bit smaller, 15, and we want to know what the sides would be. So if they're proportional, let's set up a proportion. So 16 over 20, and 16 corresponds to x, and 20 corresponds to 15. Can I simplify this? Would it help me? Yeah, it would. So if I divide by 4, I get 4/5, right? So times 3, which means that x is 12, so I know this guy is going to be 12, and therefore the other side is going to be 12. Okay, so that was part 1. And the second part is probably even easier. Can I find it? Is it here? Nope, not there. I'll find it. No, I won't find it. Nope. So it's the here it goes. Okay, so this one's really fast too. It's a map scale, right? So we're using maps. So in the map, 2 centimeters, we can write 2 centimeters is 75 miles. There are 2 cities on the map, and they're 11 centimeters apart. What's the actual distance in miles? Relationship, we can, which would be times 5.5, right? So at the bottom is times 5.5. So 75 times, 75 times 5.5 equals 75 times 5.5 equals 412 something. But in actual life, it's 412.5 miles apart. 2, floor plan, again, so again, here's my ratio, is 3 centimeters. It's going to be 4.5 meters in real life. If the actual, so if the drawing in the floor plan of the living room is 5 centimeters, what would be its measurement in real life? So here we go. So well, cross multiply 3x, etc. So I'm going to multiply. So if you cross multiply these two, right? Yeah, multiply these two and these two, we get 3x equals 4.5 times 5, which is going to give us 22.5. And then we have to divide both sides by 3. And x equals 7.5, 7.5 meters. Okay, for the length of that living. We on 3? Yep. On a map, again, you can leave it as a fraction. I probably 0.5 centimeters is 65 kilometers in real life. If the distance between Baltimore is this, this is a times 9 relationship, so we're going to multiply times 9 centimeters and kilometers. Let's see, 9 times 5 is 45, goes 4, 54. 9 times 6 is 54 plus 4, 58. I think I got this, yeah, 585 kilometers, which I don't know. Alexa, what's 300 miles in kilometers times 1.6? Sorry.
This might answer your question.
No, it might.
480 kilometers times 1
I didn't ask that.
768
I
kilometers.
really didn't ask that. So it's 480 kilometers. I was off, so I made that problem up. I was off by at least 70 kilometers. Jeez. Okay. So, anyways, it's a fictional question. 4. The floor plan of house is 2/3 of an inch equals 8 feet. And again, this one actually might need to leave it as a fraction. Inches represents 8 feet in real life. And what's the length of the basement? If it is 2.5 inches on the picture, on the floor plan, what's how many feet is in real life? So that's what we have here. So 2/3 times x, and we want to multiply that, so we get 2/3 of x equals 2.5 times 8, which is 20, right? And then we're going to do x equals 20 times 3 over 2. 20 times 3 over 2, and which is that 10, and x equals 30. The actual length of the basement is 30 feet. 5 on the blueprint, something the master bedroom has, okay, on the blueprint. So let's go 4 here, 5.5 or 5.5. If the scale is 3/4, sorry, 4 inches. So, but the scale here says that 3/4, every 3/4 of an inch, it's equal to 3 feet, right? So I can actually rewrite that. Well, that's okay. What are the dimensions of the actual of the actual master bedroom? So we can do this. I'm going to do one side at a time. So 3/4 of an inch. Let me write that portion is to 3 feet. Now we know that this side is 4 inches right here. In actuality, what would that be? So we do cross multiply again, and we're going to get 3/4, 12. We're going to go 3/4 of x equals 12, and we're going to multiply both sides by 4/3. If you don't have a calculator, and 4 and x equals 16. So in real life, that would be 16, and now I have to do one more time, which is the length here. So I'm going to set up everything again, except that this time instead of 4, the drawing says it's 5.5 inches. And what does that 5.5 inches represent in feet in real life? So again, all that good stuff, 3 times what? So we're going to get 3 times 5.5, which equals 16.5. And x times 3/4, and I'm going to leave it as a fraction, decimal, and 0.75x, divide both sides by 0.75. And our length here is going to be 16.5 divided by 0.75, and that's going to give us 22. So the master bedroom has these two dimensions, is 16 by 22. 6. Model trees being built using a scale of 1 inch is 25 feet. So that's what I know. All right. What's the actual height of the tree if the height of the model is 4 3/8 inches? So if on the model that you're creating, your tree measures this much, what's this height in real life? Well, this one's nice and easy because all you gotta do is multiply 25 times 4 3/8, and that equals, hang on a second, 4 3/8. So, so 4 3/8 can be written as 4.375, and I'm only doing that because my calculator deals fractions. So I'm going to multiply that times 25. 4.375 times 25, and in actuality, that tree is, well, we round it to the nearest hundred, 100.9.38 feet tall. Scale on the map is 1 to 55. Seriously. 1 inch is 55 miles. And if they're actually 99 miles apart, that's the distance on the map. Okay, so this is going to be 55x equals 99. Divide both sides by 55. And x equals, I have no idea, 99. Dividido por 55 é 18. Oh, look at, really? 1.8. 1.8 inches on the map. Okay. 8. The statue of Thomas Jefferson, okay, and you see was using a scale of 1 every 1/5 of a foot. Represents 2.5. Okay. So if the statue, oh wow, every 1/5 of a foot of Thomas Jefferson equals to 2 1/5 of a foot of the actual monument. Not kidding, I didn't know that. All right, so that's the relationship. So, and if the statue, so this is actually, I'm gonna write TJ, Thomas Jefferson, and this is the actual statue. All right, so if the statue was 66 feet tall, how tall was Mr. our President, Thomas Jefferson? That's my x. So again, you're probably better off, I think. Well, I am better off. And change. I'm going to change this whole thing to 66x, and 1/5 is 0.2, and at the bottom is 2.2. That's what I get. So cross multiply 2.2x equals to 0.2 times 66, and that's going to give me a 13.2. And I divide that by 2.2, and I'm going to get that x equals 6. So Thomas Jefferson was 6 feet tall. 9, use your actual ruler. So I'm going to skip that because I can't do that. Number 10. So again, you just got to make sure that this picture, when you're doing something like this, that you label them correctly. So VS is 3, TU is 6, and VU is 9. On the other picture, it says that XY is 3, ZY is 3, ZW is 1, and XY is 2. Okay. What's the scale factor from STV to WYZ stuff? So we're going from big to small, right? So what you need to do is pick any two corresponding sides. So let's pick this one because this 9 corresponds with what value? That 9 would be the 3, right? That's this side over here corresponds to this side over here. If you were to flip it, if you think about a trapezoid, this would be one of the bases and it would be the larger base. So if you look at the other trapezoid, that larger base is represented by 3. But this one is easy, but I'm going to write it like this. So big times x equals also something on the 9, on the big trapezoid. So that 9 somehow multiplied by something that we don't know became a 3. So our scale factor, right, first of all, is going to be a number less than 1 because it's decreasing. Right, so let's solve this. Divide by 9, divide by 9, and x equals 1/3. Well, that makes sense, so because let's just try it out. 9 times 1/3 is indeed 9 times 1 is 9, divided by 3 is indeed 3. And if you were to just try it out again, let's pick this height. The height of our trapezoid was 3. And what did it become on the smaller trapezoid? It became 1. So is 3 times 1/3 1? Yes, it is. So you can tell that our scale factor here is correct. 11. Each hexagon has exact side measurements. Determine the scale factor from the smaller, so we're going to smaller to big. Nice. If the larger hexagon has a perimeter of 48. Well, 1, 2, 3, 4, 5, 6. So if it's 48 and divided by 6, it means that every side is 8. 8, 8, 8, 8, 8. The small one has a perimeter of 12. So again, and it has 6 sides. 1, 2, 3, 4, 5, 6. And 12 divided by 6 is 2. So each side measures 2. So obviously, one, if you would need to take any of the sides. So the scale factor here, in order to find our scale factor represented by x, 2 times the scale factor, turned out to be 8. And we already know the answer that the scale factor is going to be 4. So the scale factor, in this case, from small to big is 4. Okay. If the patio has dimensions, what's the scale factor? Okay. Well, oops. Just hang on a second. I need to get something. So for this question, let's see. Let's draw it out. So we have a patio that has dimensions 5.5, 5.5 centimeters, and by 7 centimeters. And the actual dimensions, the patio has dimension, and the actual dimensions has from the drawing. All right. So obviously that's the drawing, and the actual. This is 700 centimeters, and this is 500 centimeters, which is 5 meters and 7 meters, right? What was the scale factor from the drawing to the actual patio? Well, either you pick this corresponding side or the bottom corresponding side. So we're going from small, so the small multiplied by the scale factor gave you, right, the new number, the big number over here. Let's stick to this one. Obviously, we know what the answer is. But the 7 times the scale factor of x that I get to know somehow grew to 700. So what was the scale factor? Obviously, divide by 7, divide by 7, and the scale factor was a scale factor of 100. Small to big. 13. 2 rectangles below, blah, 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 have proportional. The area of rectangle A is 40 centimeters squared, and P measures 5 centimeters. So if this is 5, obviously this is going to be 8 because the total area is 40 centimeters squared, right? The area of rectangle B is 1.6, which is, and the side S, this side over here, is 1.6 centimeters, or whatever this is. Yes, centimeters. This is centimeters, this is centimeters, which means R is 1, right? Because the area is 1.6 centimeters. So, where's the scale factor from triangle A to triangle B? So we're going from big, multiplied by our scale factor will give us our small value, right? So let's pick, I don't know, any side. So either the 8 and the 1.6 or the 5 and the 1. Let's pick the 5 and 1 because that to me is easier. So it was 5. We multiplied by our scale factor, which means in this case got reduced, and it became 1. Obviously, our number has to be less than 1. Divide by 5, divide by 5, and the scale factor here used was 1/5. So we reduced everything by that. And just to verify that, so the 8 over here, multiply the scale factor of 1/5, is that equal to 1.6? Right? Because this multiplied by 1/5 should give us our new proportional side here. And 8, and you can clearly tell that 8 divided by 5 is 1.6. Right? So our scale factor of 1/5 works out. Well, that's it. Wow, that was kind of simple. And